Okay, guys, so this is lesson number 2 for Learning Guide 1. We're going to talk about angle properties in triangles, angle properties in polygons. And I'm going to split this one up into part A and part B, just so they're not quite so long. All right, so first of all, just a little bit of recall information. If I look at triangles here, it's saying the sum of the interior angles of a triangle must add up to 180 degrees. What that means is if I've got this triangle here, okay, I know this plus this has to equal 180 degrees. That works for every single triangle. If I look for the exterior angle, so the exterior angle here, that's our outside angle. So if I draw my triangle, okay, and then I extend one of the legs. So for instance, this. I've just created an angle right here, which again we're going to call exterior. If I do the same up here at this point, if I, let's say, extend this this line, I've just created an angle here. So we could even call that one E. That would be another exterior angle. If I did one more, so if I follow this line here and extended it, this would be another exterior angle. So we could even call that F. If we look at a couple of examples, what you guys are actually going to see in Math 20-2, which is a little bit different than the Math 20-1, is we're actually going to need to do some proofs. And what a proof is it's saying, okay, well, what is this angle? Solve for that angle, but then prove to me what you did is actually mathematically sound. Prove and explain your method. So if we look at the first example, it's saying in the diagram, angle MTH, so angle MTH, all you need to do is follow the letters. So MTH is 155 degrees, and it is an exterior angle of the triangle MAT. Determine the measures of the unknown angles in triangle MAT. Well, we already know one of these angles. It's 40 degrees. We know, according to the other page that we just did, we know all the angles have to equal 180, but we're missing two angles here. We're missing the angle at A and the angle at MTA. The first thing that we want to do is take a look to see which one we can solve for first. Well, guys, if we look at this table here, we've got our statement and our justification. So statement means, okay, solve for something, and then justification means, okay, well, tell me what you did and how you did it. So the first one, hopefully you guys are looking at being able to solve, is this guy right here. Because this lies on a straight line, and I've mentioned it already quite a few times, look for those straight lines, and we know that they add up to 180 degrees. So we can write in here, angle MTA has to be equal to 180 minus 155. And that's going to give us an angle of 25 degrees. So we know right here, we've got 25. Now justification, if I fill in this table and explain what did we do, I could literally just say it lies on a straight line. That's all I mean by justification. Tell me what you did, why it works. Now the last angle, which is angle A, if you guys notice, if you just kind of focus on this triangle now, I've got this angle, I've got this angle. In order to solve for my third angle, we can look back at the last page and say, okay, they all have to add up to 180. So angle MAT must be equal to 180 minus 40 minus 25. And that's going to give us 115 degrees. What is our justification? Again, why do we know to minus it from 180? Well, we know the sum of interior angles of a triangle is 180 degrees. Okay? So what you guys are again expected to do in Math 20-2 is not only find the angle, figure it out using the rules, you need to tell me in words why did it work? How did you do it? Why does it make sense? Next, it's talking about a little bit more specifically about these exterior angles. It's saying the exterior angle of a triangle is equal to the sum of the two non-adjacent interior angles. So remember we've talked about exterior angles already. That's the outside angle. And what this rule is actually saying is if I take the opposite inside angle, so not the one that's connected, but the opposite ones, and I add these together, I'm going to get this angle. So angle 1 plus angle 2 is equal to angle 3. If we look at an example here, example number 2, it's asking us solve for x. Now we could do this a couple different ways. Number 1, we could say, okay, well, wait a minute, that lies on a straight line. So I know that 180 minus 70 is equal to 110, and that must be equal to x. The other way of doing this, and this is kind of using the method or the rule that we just talked about here, I can say, okay, well, this is the exterior angle, so I know this plus this, so the opposite interior angles must be equal to this. So 40 plus 70 is equal to 110. And you guys can see we get, obviously, the exact same answer. Example number 3 is asking us, okay, we've given you a bunch of information. We talked in the last lesson about, the Z rule, the Y rule, the F rule, all of those guys. And now we're talking about triangles and exterior angles. Let's say we want to determine the measures of a whole bunch of angles given this diagram. You need to now apply all that information that we just talked about. So if I take a look at saying determine the measures of angle N, M, O, so we're looking for this guy here. We're looking for M, N, O. So we're looking for this guy here. And QMO. So QMO, we're looking for this guy here. So again, if you have trouble with that, you just follow the letters. And then obviously it's saying justify your answer. So we can do that in our table here. One of the first things that we need to look at, like a lot of students look at these questions and they're like, what do I do? I don't know where to start. Okay, so if we just take a look at what we're given here, we can see that we've got parallel lines. So right away with a parallel line, you know that we are given a transversal, which again, you know from the last lesson, gives us a whole bunch of different rules that we can remember. So if I just take a look at this line here, so this parallel line, and this transversal. Hopefully what you guys can see is the Z rule. If this is 67, then this whole thing must be 67 as well. And we can actually use that to help us solve for one of those angles. So let's write down what we've talked about already. We know that angle MNP, so MNP, which is this angle here, must be equal to 67 degrees. Don't forget to justify. Why is that right? Well, this is the Z rule, but guys, remember Z, all these letters are something that I just kind of made up to make it a little bit easier for things to look at. You still need to know the actual terminology. So this is actually called the alternate interior angles rule. So that's all we really need to put for our justification. It's the alternate interior angles rule. Now, like we said, we can use that information to help us solve for something that we really want, because that's not actually one of the angles they're asking us to solve for. If I know this whole thing here is 67, and I know this little guy is 20, well, it's pretty easy to find that missing angle. All we need to do is say, okay, well, angle MNO must be equal to 67 minus 20. Now that's going to give us 47 degrees. Now, what would be the justification for that? Well, we know that 20 plus 47 must equal 67, so we can just call that the sum of the angles. The angles must equal 67. Now, let's move on. So we've got this guy here is 47 degrees. I've got my 20 degrees, my 39, my 67. Now remember, one of the angles that we want to solve for is NMO, which is this here. Hopefully you guys can take a look and see, ooh, that's a triangle. So this here, here, here is a triangle. And remember what we said, all the angles of a triangle must add up to 180. So angle NMO must be equal to 180 minus 67, minus 47, minus 39, and that's going to give us a grand total of 94 degrees. So this angle here must be 94. Now, what's the justification? What did we do? Well, we remembered that all the angles in a triangle add up to 180. So we can just say that's the interior angles of a triangle. Add to 180. Now we've got one angle left, which is this little guy right here. That's our QMO. Again, I've mentioned it a million times. What do this angle and this angle and this angle all do? Well, they lie on a straight line, so they have to add up to 180 degrees. So angle QMO must be equal to 180 minus 67 minus 94, which gives us 19 degrees. What's the justification of that? All you would need to say is it's a straight line. Okay, so again, what we're doing here is we're using all that information and we're applying it onto solving for angles and actually being able to justify our answer. So I'm going to stop there. Don't forget to watch for part B to go over the second part of this lesson.